Hello, welcome, and thank you for joining us here in the Void. I'm Science Ben, Immersive Experiences Coordinator for the Danville Science Center, and your host for today's tour of the night sky for the month of August 2021. Today's virtual online interstellar discussion is presented by our friends at Danakid Associates, and as always is interactive. If you have any questions, any way that you wish to participate throughout our chat, just post those in the comments section, and I will go back at some point, usually the end, and attempt to respond to some of those. If you miss any of today's conversation of our tour, of any of our live broadcasts, you can always go back and view recordings, include not just this one, but past recordings on the Danville Science Center's Facebook page and, of course, YouTube. But today, we're going to look at our sky. Let's discover our world. We begin, as we always do, here outside of the Digital Dome Theater at the Danville Science Center. We are facing the southern sky, and if we take a few steps back, we see that to our right is the west, to our left is the east, meaning that north is directly behind us. If we look in the corner, we can tell that it's just a few moments past noon on the 12th of August 2021, and gazing skyward, we can see our friend, our bright G2 yellow star, the sun, shining brightly down upon us. Today's sun is joined to the left of the sky from our viewing perspective by a young waxing crescent moon, the first phase that follows a new moon. If we continue to follow our moon into the west, we're going to zoom out just a little bit and keeping our eye on the western horizon. And then we're going to start moving through time to just about evening twilight, right around 8 o'clock. Doing this, and again, gazing in the west, we can spot not one, but 3 planets orbiting nearby. We'll go a little bit further, let's say about 8:30. Again, keep your eyes on the sun, and we start to see, on the moon, not the sun, on the moon, and we start to see an object kind of close to it. Of course, this is the 3rd brightest object in our sky next to the moon and the sun. This is the planet Venus. Not today, but tomorrow, Venus and the moon will be even closer. Venus will reach full lunar conjunction tomorrow night. That's where the 2 lights appear to be the same size in the sky from our perspective. Extremely difficult to see, but it's there. Unfortunately, the sun is a little bit too bright. Is the next planet that we are curious at looking at. If I add a little circle, you may just barely spot Mercury. Again, to actually see that in tonight's sky is going to be tough because of the sun's glow. If we go a little bit further, until Mercury just does descend past the horizon, we get to see our 3rd planet in tonight's sky, early sky, of course, Mars, which you may be able to see. Again, it'll be a little tough given its time of day, but if you've got a nice clear tree line, you will be able to see it in tonight's sky. All this by using the moon as our guide. And sure enough, the moon is going to be our guide for some more celestial viewing in tonight's sky. Again, start with our moon. Right there, that's Venus, that's the moon, Venus, moon. Start with the moon and try drawing an imaginary line straight up and to the right, boop, 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 to find Alkaid, the 38th brightest star in the sky and the very tip of the tail of the Great Bear, Ursa Major. I'm going to remove the edge of this building so we get a little bit better view of Ursa Major. Within Ursa Major, the outline, we actually can find the asterism of the Big Dipper. Going to the Big Dipper, this will help us again find our next destination. Go right to the spoon of the Big Dipper, and again, draw a line straight up and to the right to find the tail of the Little Dipper, or of Ursa Minor, the Lesser Bear. Excuse me. This star, designating Alpha Ursae Minoris, common name Polaris, is one of the most useful and important stars in history. Polaris resides nearly in a direct line with Earth's rotational axis above the North Pole. This location grants it the designation as Earth's pole star, or the North Star. But this wasn't always the case. Every 26,000 years, the Earth's axis points to a new star. In 3000 BCE, the North Star was Thuban, found in Draco the Dragon. Parts of the Great Pyramid of Giza are actually aligned with this position of Thuban and would have appeared. They're aligned. The North Star does change every 26,000 years or so. That's because our Earth is not completely round. It's a sphere, but it's an irregular sphere. In fact, it kind of bulges out at its midsection like a jelly-filled donut. Too many jelly-filled donuts and you'll bulge out in your midsection. Fortunately, the Earth does stay active. Thanks to its rotation on its axis as well as its revolution around our sun, this has an effect on the Earth. Gravity is constantly causing its changing, and because of this movement combined with an irregular shape, that means that our planet ever so slowly wobbles, kind of like a toy top. How slowly? 26,000 years slowly. Because of this wobble, the Earth's irregular shape causes the gravitational effect of the sun of the Earth to be unbalanced, thus the wobble. This causes the Earth's axis to spin, completing one revolution every 26,000 years. So there will be another North Star, probably in the year 4000, but chances are we won't see it. Given its very prominent position, Polaris can and has for centuries been used for navigation. Throughout the night, Earth's rotation causes more stars to appear to change location. Most stars to appear to change location. At 8:30 tonight, we can make out Leo the Lion in the west. By 9 o'clock, the lion appears to have retreated for the evening, descending past the visible horizon. Polaris, however, appears to stay in roughly the same place. As explorers moved through their travels, they knew if they followed the star that appeared not to move, then they were surely facing north and could derive the trajectory from that point on. This position means that not only does Polaris never descend past the horizon, but also that there is a group of constellations that appear to closely circle it, which can be seen all year round. For the northern hemisphere, there are 9 circumpolar constellations that can be viewed during all 4 seasons. Perhaps the most well-known are the first introduced in today's Void, the mother-son team of Ursa Major and Ursa Minor. Roman legend has it that Jupiter, king of the gods, was attracted to Dionysian nymph Callisto. Jealous, Jupiter's wife Juno transformed Callisto into a bear to deter Jupiter's desire. Callisto's son Arcas was known to be a skilled hunter. Not recognizing her, one day Arcas almost shoots Callisto with an arrow, but just before he does, Jupiter transforms him into a bear and places both mother and son in the heavens for protection. Callisto and Arcas now populate the skies in their bear forms for all eternity. Cephas, Cassiopeia, and Perseus, along with non-circumpolar constellation Andromeda, are the main characters of several well-known Greek myths, some of which are surveyed in the film Clash of the Titans. To learn more about them, we watched last August's Void, when Perseus was a focus. Draco is an S-shaped dragon hurled to the sky in an arc by another great Greek hero, Hercules. A relatively new constellation, new meaning designated in the year 1687, the constellation Lynx is inspired by the feline animal it is intended to represent. Perhaps my favorite circumpolar constellation asks what animal looks like a cross between a camel and a leopard. Camelopardalis forms the outline of a giraffe. Finally, Auriga, say that wrong, that's a hard one for me to say, the supposed inventor of the 4-horse chariot, completes our nonupple of northern circumpolar arrangements. Again, these arrangements can be seen from locations in the northern hemisphere on any given night throughout the year. And to give you a better idea of that, I'm going to put the edge of the building back up. We are going to deselect Ursa Major and Ursa Minor, but again, keep your eyes focused on Polaris right there in the tail of Ursa Minor. If we clear those, but then put up all visible constellations, and we move through time. Oh, wrong way. We're gonna move forward through time, not backwards. Well, that was backwards. Anyway, we're gonna move through time. Stay focused on Polaris, and you can see these series of constellations orbiting around it. There's Draco, there's King Cephas, Queen Cassiopeia, our hero Perseus, holding the head of Medusa, the oh so wonderful Camelopardalis, which is also just fun to say. And then there is our charioteer? Let's see. Nope, that's Boots. There's Lynx bringing around, and again, they all can be seen at different times, or some major coming back up. Again, we call these circumpolar, and we can see them all year round. Something, though, that is much more unique to get a view of, and is actually viewed best around the poles, north and south, is something kind of unique that is worth seeing. If you joined us for June's Void, then you will remember that in addition to global amounts of heat and light, the sun also produces a massive amount of energy. Sometimes this energy breaks away from the sun in solar storms known as coronal mass ejections. CMEs are blobs of electrified gas called plasma traveling at high speed through space. It can take just 18 hours for one of these flares to travel the 93 million miles it takes to get to Earth. These energy blobs can affect satellites, including GPS that orbit the planet, in addition to harming power grids and blocking out radio waves here on Earth. Fortunately, our planet has a protector from the full force of space weather, the magnetosphere. You may already know that the Earth can act like a big magnet. That is what makes a standard compass needle point north. This behavior is believed to be a direct result of Earth's iron outer core. Like a bar magnet, Earth's magnetic field has two ends, a north and south pole. This field actually extends far beyond Earth's crust, past the atmosphere and out into space. The region of space where Earth's magnetic field is dominant is known as the magnetosphere. The magnetosphere helps dissipate and transfer solar radiation around Earth, but the field does have weak spots, specifically at the Earth's poles. Particularly strong solar storms can produce charged particles that can actually travel down magnetic field lines, entering Earth's atmosphere. When these particles interact with planetary gases, they produce massive, natural, beautiful light shows known as aurora. Mixing with oxygen gives off green and red light, while mixing with nitrogen glows blue and purple. These lights are best viewed at the poles. At the North Pole, they are called the aurora borealis, or northern lights, and at the South Pole, they are called the aurora australis, or southern lights. Earth, though, is not the only planet to experience this beautiful display of extreme power. All of the outer planets, and perhaps even Mars, experience aurora. Those on Jupiter and Saturn have been recorded to beautiful images on multiple occasions. Speaking of other planets, quick check-in on Mars. As of last Thursday, August 5th, the Curiosity Mars rover officially turned 9. The car-sized rover has spent 3,204 Martian days on the rust planet, making such major discoveries as sedimentary rock, the presence of noble gases, and capturing the first ever recording of the trail of one of Mars's famous dust devils. Happy birthday, Curiosity. Boop. There we are. Sorry about that. Has your curiosity been sparked? Is it your birthday? Do you just want a shout out? Now is the part of our tour where I respond to some viewer submitted content. You can participate by posting in the chat for this feed. As we are waiting, because again, this is a live feed, so I'm a little ahead. Today I'm about 7 seconds ahead of your posts. It is worth mentioning, I meant to mention it earlier, but didn't, that this coming tomorrow, Wednesday night, late Wednesday night into Thursday morning, you want to look towards our pole star, particularly towards the constellation of Perseus, and you may see some of those stars racing across the sky. The Perseid meteor shower does peak again Wednesday night into Thursday morning, and this tends to be one of the more visible, more active meteor showers of the year, especially given that this week our moon is not particularly bright. It's still pretty young, still pretty small, so you should be able to spot some of those shooting stars here in Virginia. Again, as always, you want to find a nice dark spot away from artificial light. Go out early morning is probably your best chance. Watch out for a high tree line, and you may just see the Perseid meteor shower. It'll last for another more weeks. It just peaks tomorrow night, Thursday morning. It is worth a look. You do not have to look directly at Perseus. It's a pretty broad ranging shower. It's just that it radiates. Its radiant point, again, is in Perseus, the constellation Perseus, the hero. Well, again, as always, we thank you for joining us here in the Void. If we didn't get to your question today, by all means, send those to us on the Danville Science Center Facebook page. They don't have to be during the presentation. I can always come back for our next one and respond to any lingering queries. But until that next time, until next month, we thank you for joining us for the Void. We thank you for joining us. It's August. I'm really glad you hung out while we looked at the stars. This month, just like every month, is presented by the awesome people at Danakid Associates. They are wonderful and are great at what they do. We hope that you think we're great at what we do at touring the night sky, so much so that you choose to join us next month, again, as we journey into the Void. It will be the second Tuesday of September, the 14th. Until then, by all means, please stay healthy, stay safe, and of course, stay curious. Goodbye.